Good evening, Sarita ma'am.
Yeah, good evening, ma'am.
Ma'am, we wait for 5 minutes until all participants will join, and then
Huh,
we start.
sure, no problem.
Okay, ma'am.
अरे फोन करो यार, लाइट क्यों नहीं आ रही है?
मुझसे इतना मैसेज आया था, अपना मैसेज हो गया।
हम्म?
बीच में हम फोन किए थे, पूरा बंद रहा है और वो बना भी था, लेकिन फिर बाद में क्या हुआ।
Shishma madam, I have joined. Now you can start.
Yes, sir. Good evening to all participants. Today is the third day of our 1 week FDP. Today we have with us Dr. Sarita Kalla. She is an assistant professor in chemical engineering at Sardar Vallabhbhai National Institute of Technology, that is SVNIT Surat, with over 7 years of academic and research experience. She holds a PhD from MNIT Jaipur, an MTech with honors from Aligarh Muslim University, and a BE from University of Rajasthan. Her research expertise spans desalination and wastewater treatment, metal organic frameworks, MOF based membranes, and membrane separation technologies. Dr. Kalla is the co-founder of the startup Solar Pure, which is focused on sustainable wastewater purification solutions. She holds 4 Indian patents related to MOF and MOF incorporated membranes, has published 36 plus research articles, authored 3 book chapters, registered 3 designs, and is currently supervising 6 PhD and 2 postgraduate students. Her work has received multiple prestigious recognitions, including IICHE Chemical Weekly Prize, the Professor Shamlal Kanti Sanyal Memorial Award for Best PhD Thesis, a top viewed review article in Chemistry Select in 2023, and first prize at CHES 25, IIT Gandhinagar and SVNIT. She is also actively involved in organizing conferences, SVTPs, workshops, and delivering invited expert talks at national and international forums. Now I request Madam to proceed with her session on membrane technology. Thank you. Over to you, Madam.
Okay, thank you, Dr. Shushma, for such a nice introduction. So, am
Yes,
I audible?
yes,
Okay,
ma'am.
okay. So I'll share my screen. My slides are visible.
Yes, ma'am.
Okay, thank you. Okay, now it is fine. It is full screen.
Yes, ma'am.
Okay, thank you. Okay. So, uh, good evening, everyone. So today, my topic for the presentation is membrane technology, and in which I'm going to cover some theory part and then case studies. Okay. So these are the agenda of today's session. So on the basis of the theme of this FDP, I selected only those part of my research work that comes under the theme of this FDP. So first we'll see that why this wastewater treatment is required. Then we will see the different membrane separation processes, simply outlines of different membrane separation processes. Then this type of membranes we can use. Then this membrane can be prepared or can be synthesized by different additives. So one by one we will see that how these additives are helpful in wastewater treatment. So this membranes includes nanoparticle enhanced hydrophobic membranes, MOF incorporated membranes, hollow fiber membranes, MCOF membranes, and then further MF membranes. So if time permits, so we will discuss that also. Fine. So we all know that, of course, the water is very the hypersaline water that is generally having the salinity level 7 to 8 times of the normally available water. So that generally comes from in the form of produced water, geothermal brines, dye containing wastewater, etc. So we are having different treatment processes for this hypersaline wastewater. So, but this conventional water treatment process involves screening, coagulation, flocculation, sedimentation, filtration, and disinfection. But this conventional wastewater treatment processes are reliable. Of course, they are reliable, and but they simultaneously they are facing different drawbacks like high operational cost, energy consumptions, and simultaneously generation of sludge and brine waste. So, and we are also struggling in removing certain contaminants that are not possible to remove using this conventional techniques like pathogens, nutrients, and soluble non-biodegradable chemicals. So for this as a substitute of this conventional water treatment processes, we can use different membrane separation processes. Okay, so we'll see that what are the most commonly used membrane separation processes, their principle and applications. Fine. So first one is membrane distillation. So this membrane distillation is one of the emerging membrane separation processes in which it is basically a thermal driven membrane separation processes. So in here the difference between this membrane distillation and other membrane separation processes is that here in this case only vapors are going to pass through the membrane. So you can see here these are the different configuration of membrane distillation, and it is thermal driven. As I already said, thermal driven. So what happens here? Simply, whenever we are applying some feed into this membrane distillation process, so this feed is initially heat up. We have to increase the temperature of feed, and generally the temperature range is between 50 to 80 degrees centigrade. So we are not going to increase the temperature more than 80. Why this is so? Because if we are going to increase the temperature above 75 or 80, then membranes start degrade. Okay, because membranes are generally made up of polymers. So polymers are start degrading after 75 or 80 degrees centigrade temperature, and if membranes start degrading, then our process becomes fail. So here in this case we are simply going to heat the feed, and whenever we are heating the feed, the vapors are produced. Of course we are having water, so water start boiling at above 0 Kelvin temperature. So whenever we are going to heat the feed, the vapors are produced, and these vapors are passed through the membrane. So here not liquid is passing, here the vapor are passing through the membrane, and we are going to collect the vapor at the permeate site. So this is a first type of membrane distillation in which is called as DCMD, or direct contact membrane distillation, in which why it is called direct contact, because membrane is in direct contact with the permeate. So you can see here it is direct contact. So here some cooling water is flowing, and this vapor get mixed with this cooling water, and we can collect the permeate. So whatever volume is increased of permeate, that will give us the value of flux. So flux is simply amount of water collected in liter per meter square per hour. Means whatever the area of your membrane, so we are going to divide it by this the amount of water collected and with the time. Fine. So this is simply a DCMD. Second one is AGMD. So air gap membrane distillation. So here in simply you can see we are maintaining some air gap between the membrane, and this is your plate. Okay, there is some cooling plate is some plate is there, and other side of the plate some cooling water is flowing. Okay, so when vapor comes in contact with this plate, so this plate is generally made up of SS. So whenever this vapor comes in contact with this plate, so due to in the other side some cold fluid is flowing, so this vapor get condensed when it come in contact with this cooling plate, and we can collect the vapors in the form of a liquid. Okay, so this is simply called as condensing plate, and we can take this liquid or permeate out. So here we are maintaining some gap. So in this gap we are generally having some air, or you can use some inert gases. Okay. The other one is vacuum membrane distillation. So vacuum membrane distillation is same as DCMD, but here what we are using. So in the first and second case, we are collecting the permeate inside the module. Okay, so this complete design is known as module. Module membrane module means the module means the part of the setup in which we are installing a membrane. Okay, so in the third or fourth case, we are collecting the permeate outside the module. Okay, so you can see here feed is flowing at the upper side of the membrane, vapor passes through the membrane, and these vapors are condensed outside the module by using some vacuum. Okay. Okay, so we are using some vacuum pump. This vacuum pump is going to suck the vapor, and we can collect this permeate outside the module. So therefore, it is known as vacuum membrane distillation. So you can understand by the name itself also that if we are using VMD, then we are using vacuum. DCMD, we are maintaining the direct contact of the vapor with the permeate. In air gap, we are maintaining some gap. Okay, and the last one is swift gas membrane distillation, or SCMD. So here simply what we are doing, we are using some gas. Okay, so that again this gas can be some inert type like nitrogen, argon. Okay, so we can use that type of gas. So this vapor, whenever this vapor pass through the membrane, it get mixed with the gas, and we are going to collect this gas outside the module with the help of some condenser, and we can have the final permeate. Fine. So these are the main this actually in any type of membrane separation process, the heart of the process is membrane. Okay, we simply say that the complete process depends on the membrane, that which type of membrane you are using, what is its properties. Okay, so we will discuss later on that how this membrane are prepared, but these are the simple outline or functioning of the MD. So depending on the way by which you are collecting the permeate, this MD are classified into four types: DCMD, AGMD, VMD, and SCMD. Fine. Then nanofiltration. So this first one is MD. Okay, second one. So most of you, I think, know about the nanofiltration because it is most popularly used and the most commonly used membrane separation process. So this figure is schematic diagram of nanofiltration setup that we are having in our lab. Okay, so whatever process I am going to show here. So all the setup are available in our lab, and my students are working on that. So you can see it's simply this in the nanofiltration process. We are using nanofiltration membrane, and it is pressure driven separation process. So MD is thermal driven membrane separation process, and nanofiltration is pressure driven membrane separation process that we all know. Okay, so this nanofiltration membrane is capable of removing the contaminant of size less than 0.001 micron, and this nanofiltration membrane really removes all type of bacteria, virus, organic matter, divalent ions, and up to 90% of monovalent ions. Okay, so it depends means which type of feed you are using. According to that, you can select your membrane process. Fine. So we are selecting in our lab is depending on the feed, which type of feed we are using, and uh, membrane, which type of membrane we have prepared. Okay, so in the case of MD, the membrane used are hydrophobic. Okay, so I think all of you know about the hydrophobic or hydrophilic membrane. So in MD, we are using hydrophobic membrane. So I will discuss later on about this hydrophobic membrane. So see, it's simply a schematic diagram of nanofiltration setup. So here we can see simply we are having some pump. This is your membrane setup, or we can say membrane module. Okay, so here this feed will go through the pump into the membrane setup, and we are going to collect the permeate to the other side. And the purity of this permeate can be measured using a conductivity meter, thermal conductivity meter or conductor meter. And these are the pressure valves, means if whatever the part is not filtered or not passed through the membrane, that can comes back to the feed tank, right? Okay, then okay, the next is membrane bioreactor. Okay, so again this setup is available in our lab also. So here this membrane bioreactor is you can understand by the name itself also that it is a combination of this biotreatment or filtration treatment. So biotreatment means here we are using some microorganisms. So these microorganisms are used to degrade the organic matter present in the feed. Okay. So once this microorganism break the organic matter present in the feed, then the feed again pass through some filtration medium. So filtration medium in the membrane that we can use in the filtration medium is maybe microfiltration membrane or ultrafiltration membrane. It depends. Okay, you can use micro or ultrafiltration membrane. Fine. So it works in two ways. Means two what we can say, two techniques are used in the membrane bioreactors. So microorganism for bioterm, and then because degradation is there, organic matter degradation is there, so some reaction is there, so therefore it is known as bioreactor. Fine. So you can see it's simply okay, and then some aeration system is also used. So it is only used to provide the oxygen to the microorganism so that they can survive or they can degrade the organic matter that present in the feed. Fine. So this is simple air blower by which we are providing the radiation. Okay, so here, okay, one more thing. The membrane that we generally use in the any membrane separation process can be a flat sheet, can be a hollow fiber. Fine. So here in this setup, you can see hollow fiber membrane. Okay. So what is that? I'll explain, but it's simply in the form of fiber. Hollow fiber means they like a pipe. Okay, we generally see the this water pipe. It is like that only. So we will see. Okay, so this is simply generally used for this the feed containing this biomaterial, means some organic matter. So in that case, we can go for the membrane bioreactor process. So we have already worked on this municipal wastewater treatment. Okay, so in this one of my students are currently working on this municipal wastewater treatment. So we collected the sample from the this from the Surat itself, and we treated that sample through MBR, and we observe a very good results. But again here, the main part is membrane. So we prepared the membrane also, but that we will discuss. Okay. So this is about membrane bioreactor. Then, okay, the another process is pervaporation. Okay. So I think you know about this pervaporation. So it again here in this case, what happens in the MD? What we have discussed, that vapor is going to pass through the membrane because we are going to heat the feed. Vapor is generated and it is going to pass through the membrane. But here in this case, what we are using, we are going to use some liquid mixture or liquid feed mixture, and this liquid will pass through the membrane. And after passing through the membrane, you can see here, after passing through the membrane, at the other side or permeate side, it is going to convert into the vapor. And how it is going to convert into the vapor? So you can see here we are using some vacuum pump. Fine. And this simply, you can see pervaporation is a combination of permeation or sublimation and evaporation. Means first liquid is going to permeate through the membrane, and the other side, at the permeate side, it is going to evaporate and convert into the vapor form. Therefore, it is known as pervaporation. Fine. So again, we are going to design the membrane here in such a way that it is permeable or selective for one of the components. Means you are using some feed, it is a combination of two components. So this membrane should be selective for one component. Means one component is able to pass through the membrane, and it is going to convert into the vapor into the other side by using vacuum. So you can see here, this is your this schematic diagram of this setup, the rotation setup. So same thing is there. So this is your membrane module, and this is your feed collection tank, means water tank and feed collection. So whenever we are going to collect this vapor is passed through the membrane, so we are going to collect it into the collection tank. Fine, and with the help of some vacuum pump. Fine. So it simply means, I think you can understand that what is the difference between MD and pervaporation. Okay, so in MD, the vapor is already created at the feed side, and then it is going to pass through the membrane, and we are going to collect it into the permeate side. But here, in this case, we are this means this feed is passing through the membrane in the liquid form, and then it is converting to the vapor in permeate side. Okay, so this is about the pervaporation. Okay. Then another is electrodialysis and reverse electrodialysis. So currently we are not working in this, but we have already submitted one project on this. So let's see what will happen. But I just want to give, because we are talking about the memory separation process, so I just want to give a brief idea about this ED and RED. So simple, it is this ED electrodialysis or RED. Electrodialysis are electrochemical memory separation process. Right. So in the case of ED, we are using electrical potential as a driving force, and in RED, we are using concentration difference. So this ED is mainly used for the desalination purpose, for desalination, because it is using some power, some electric source. Okay, and here we are having, you can see here, we are having a stack of the membrane, okay, the or anion or cation membrane, and in between this membrane some electrode is there. Fine. So the positive charge ion will attract towards the negative charge, this membrane, and then negative charge ions attracted towards the positive charge, this membrane, and we are going to separate the ions depending on their this what we can say, this the activity. Okay. And then in the case of RED, here we are simply, it is actually basic difference is that it is used for electricity generation, because here, due to the concentration difference, okay, we are going to generate some electricity, and the same arrangement is same. Okay, means one component is in the higher concentration and another is lower concentration, and due to this concentration difference, electricity can be generated. Okay, so you can see here this orange line represent cation exchange membrane and red line is anion exchange membrane. Right. So I am just giving a brief idea about PD and RED, because we are not very much involved in these two processes. Okay, but in the future we'll see. Okay, and this is a simple picture that I have taken from some paper with pressure driven membrane separation. So all of us know about this is MF, UF, NF, and RO. So these are the membrane thickness, that membrane thickness that we use in microfiltration process, in ultrafiltration process. So in microfiltration, it is 100 to 1000 nanometer. For UF, 5 to 100 nanometer. For nanofiltration, 1 to 5 nanometer, and for RO, zero point 1 to 1 nanometer. So it simply shows that red lines show the rejection, means what component can be rejected through this membrane. Okay, so in the case of MF, these are the suspended solid bacteria virus. In the case of UF, these proteins having molecular weight greater than 10K. Then in the case of NF, it is divalent ions or trace organic component of molecular weight greater than 200, and RO, it's simply we can generally reject almost all this component, and we are getting the final, the water, and we're having very trace organic component having molecular weight less than 100. Okay, so in addition to this, they are this, I think these are the most popularly used membrane separation process. But forward osmosis is also there. Okay, that currently also very popular for use for this water treatment. Okay, so that that we will, I mean, that we are not working on this FO, but simply it is also this reverse of this reverse of just opposite of the reverse osmosis process. Okay, fine. So okay. Now, as I have already told that for any membrane separation processes, the membrane is heart of the process. Fine. So if we are talking about this MD membrane, so these membranes can be of different type. Okay, the hydrophobic, superhydrophobic, omniphobic, and Janus membrane. So the- means depending on your feed solution, whatever feed you are using for the separation purpose, according to that you have to select your membrane. Fine. So if you are working So in that case, you can go for the super hydrophobic membrane. Then, if you want to separate the feed mixture having salt and some surfactant containing mixture, so in that case you can go for the omniphobic membrane. So this what are that omniphobic? So hydrophobic means that membrane that can repel the water. Okay, so of course that I already explained that we are means in the MD vapor is only passed through the membrane. So of course it should be uh, philic for the vapors and phobic for the water. Okay, so therefore we are using hydrophobic membrane in MD, and super hydrophobic means that is having more hydrophobicity as compared to the hydrophobic membrane. Then omniphobic membrane, so it's simply used. Okay, what is omniphobic? That explain. I'll explain. And another one is Janus membrane. Janus membrane is generally used for almost all type of memory application, including salt, oil in water emulsions, surfactant containing emulsions. In all types of MD application, you can use Janus membrane. So Janus membrane is simply the membrane that you are synthesizing with a novelty. Okay, means you are using a new material, new this nanomaterial, maybe MOF, COF, MCOF, MXing. So means if you are synthesizing a completely new membrane, that can come under the Janus membrane, and it is very its hydrophobicity are very high, very high. So how we are going to measure the hydrophobicity of any membrane? So simple, you are going to measure the contact angle. Okay, means contact angle means you have to put some water drop on the membrane that you have prepared, and you just have to measure what is the contact angle of this water drop on the membrane surface. If it is very high, so it comes under the super hydrophobic or Janus, and if it is low, or so then it comes under the hydrophobic membrane. So generally we are considering 90-degree, 80-degree contact angle as a hydrophobic membrane. Fine. Okay. So this here you can see I have mentioned that it is omnivoid membrane are single or double reiterated structure type. So what is that? It's simple. You can see here. Okay, these are the Orchidia leaf. So this you can see here with this picture. They are simply having some concave like structure. Okay, means up and down and zigzag and very irregular type of structure. So means this type of structure provide very good surface roughness to the membrane. Therefore, it is known as single or double. Single or double means if double rehydrate means it is more complicated. Okay, you are adding two layer of this type of surface on the membrane. Okay, so I think you have means you know about this leaves in this is botanical term of this leaf, but we generally see Christmas tree. Okay, so it's also known as Christmas tree leaf. So what means the structure of this Christmas tree leaf is same as that of this membrane. Okay, that is having single or double rehydrate structure type membrane. Fine. Okay. So now we have seen this type of membranes. Okay, that generally used in MD. So now now I want to show you that how we can enhance the separation process by making the changes in the membranes. So that can be done. I have already told you in the starting that can be enhanced by using some additive. This additive can be a nanoparticle, can be MOF, can be MCOF. Okay, and nanoparticles can be of different types. Then MXing, fine. So that now we'll see one by one that how we can enhance the the performance of the membrane for the different type of applications. Fine. So first one is nanoparticle enhanced hydrophobic membrane. So I just want to give a brief idea about this nanomaterials. I hope everyone know about this. So these nanoparticles are very promising material that can be used to make the membrane. Okay, so this the inclusion of this variety of nanoparticles makes the membrane surface super hydrophobic. Okay, so that how they can make the membrane super hydrophobic, that I'll show you. Okay, so this the surface because there is a development of set of functional material at the surface of membrane, and ultimately what happens, it modifies the porosity and roughness of the surface, creates the functionalization of the membrane. So simply what has done here, then whenever you are going to add some nanoparticles into the membrane surface, so it will change its properties. Okay, because what happens, there should be some reaction, there should be some functionalization of the membrane, and due to this functionalization, the membrane porosity can be changed, membrane roughness can be changed. And since we require the hydrophobic surface, so this roughness can increase, and increasing the roughness ultimately lead to the increase of hydrophobicity. Fine. Porosity is also in changes. Okay. Sometimes it get increased, sometimes it get decreased. So it means that is completely a research. Okay. So means if we are successful in one part, then of course it will give you, we say you it will give you somehow a good results. Okay, not best but good results. Fine. So it depends. So okay, so what type of nanomaterials that we can use, this metals and oxides like silver, titanium, gold, and iron, and these are most commonly used, okay, for environmental mitigation purpose. Okay, and this TiO2, SiO2, Al2O3, ZNO, MWCNT, multi-walled carbon nanotubes, activated carbon, graphene oxide, and these are also very popularly used nanomaterials to form or to manufacture nanocomposite membrane, polymeric nanocomposite membrane. So here, whatever membrane we are talking about are polymeric membrane. Means we are using some polymer, right? Okay. So till now, there are different type of polymeric nanocomposite membrane has been successfully tested for membrane dissolution process, and it ultimately improve the performance of the this performance of the membrane in terms of permeate flux and rejection. So that I have already told that permeate flux is amount of permeate you are collecting per meter square of area, per meter square area of the membrane in 1 hour. Okay, and rejection means if you are using some dye containing wastewater, okay, salt containing wastewater, that how much rejection is there. So in the case of MD, there it is observed till now that there there is almost 99.9% of the rejection. That you can simply understand by the concept that in the case of MD we are using we are using hydrophobic membrane, and this membrane only allowed to pass vapor. Fine. So if vapor is going only allowed to pass through the membrane, then there will be no passing of salt. So of course you are getting a pure water in the permeate side, and there will be the complete rejection in the feed side. Fine. Okay. So this is one of the work carried out by one of my master student. Okay, and that work is published in Journal of Water Process Engineering elsewhere. So in that work we have prepared two membrane. Fine. So first one is polymeric membrane, pure polymeric membrane, PVDF membrane, and another is nanoparticle containing membrane. So you can see here in this table, the nano material that we have used is TiO2. Fine. So we prepare first membrane with by using PVDF polymer. DMF is solvent. Okay, so you need some solvent, and PEG 200. PEG is simply an additive that we have added to make to create more pores in the membrane. So it is simply a pore forming agent. PEG is simply pore forming agent that we have used and TiO2. So we prepare two membrane, one without nanomaterial. So you can see here no concentration of nanomaterial is here, and another membrane we having 0.05 gram of nanomaterial, that is TiO2. And then we tested this two membrane for methylene blue dye removal. Fine. So you can see. Okay, first. So I just want to show you the simple steps that used for the preparation of membrane in the lab. Fine. So it is generally common, okay, if you are preparing a polymeric membrane. But what happen nowadays, people are working on the commercial membrane also, means they are purchasing the membrane from from outside, and then they test it and into the process. Okay, but we are preparing membrane completely in our lab. Okay, so we are having setup for that. This membrane casting machine is there. Okay, so you can see here, these are the simple steps of fabrication of M1 and M2 membrane. So in the M1 membrane, we are having the polymer. So this bracket, in the bracket, the percentage shows the concentration. Okay, so PVDF, polymer and solvent is going to mix together. Then we are going to heat it. Okay, and stir it at the 120 rpm for 3 to 4 hours at the temperature of 60 to 80 degrees centigrade. And in that step we are going to add this PG also, and again the stirring is there. And why we are going to do that? To prepare a homogeneous dope solution. Okay, so this dope solution will prepare, and then we are going to degas it. Means if you are going to mix something there, then there will be the chances of creating some bubbles. Okay, so we have to uh, remove the bubble by degassing application. And then you can see here, this is the casting. Okay, then once the dope solution is prepared, then we are going to cast it into the membrane casting machine. Okay, and then after casting we are going to put it into the coagulation bath. So this coagulation bath is simply containing water, in which the solvent that remain on the membrane surface get evaporate or mixed with the water, and then finally we are going to dry the membrane and we get the membrane. Fine. So this the process that we are using for the membrane preparation here is phase inversion technique. Okay, so I'm not going to going in detail in that part. Okay, and the second, this is this M1 preparation, and the second we have to add TiO2. So also all the steps are same. Simply what we are going to do, we are adding TiO2 particles of 0.5% into the feed. Okay, so then we are getting M2 membrane. Fine. Okay, uh, so these are the results that we get. Okay, so one important thing that I have to mention here, that in any all type of separation process, there are some operating parameters. Fine. So in the case of MD, the operating parameters are generally feed temperature, what temperature you are using of the feed concentration. Okay, means whatever feed you are using, and then what concentration you are using. Fine. Then flow rate of the feed, and the flow rate of this cooling water also. Fine. But as per the literature, and we have already studied that the effect of cooling water flow rate is very less on the permeate, so we can ignore that. Okay, so we are taking these three operating parameters to calculate the effect of this parameter on permeate flux. So this is simply a results. Okay, we have carried out 9 experiments, and these experiments are designed by using design of experiment method, or in this case we have used Taguchi method. So by Taguchi method we have created our design, and then we have carried out the experiment, and these are the experimental results, and these are the this predicted flux that from the software, that Taguchi method we have used. Okay, so uh, after analyzing or observing the results, we found that The experiment flux is around 5.10 kg per meter square hour and predicted flux is 5.22, and these are the values of your optimum operating condition. Means these are the best results at this operating parameters. Feed temperature 65, feed concentration 75 ppm and flow rate is zero point 0.8 lpm. Fine. Okay, okay, and this shows the membrane properties. Okay, so you can see here we have measured the contact angle, porosity and thickness of the membrane of both the membrane. PVDF PEG membrane is pure PVDF membrane and the membrane containing DiO2 nanoparticles. Okay, so here in this case the contact angle is a little bit decrease in the case of M2 membrane, but porosity increases. Fine, and thickness remain the same. Okay, so you can see here the final result simply shows that whenever we are means when we are adding TiO2 nanoparticles into the membrane, then there will be the increase in the flux of. Okay, I request participants to please mute your mic. Okay, so in the case of M2 membrane, you can see the flux is 6.22 kg per meter square, which is 21.96% higher as compared to M1 membrane. So simply the addition of DiO2 nanoparticles will increase your flux. Fine. And the color rejection, so as I have already told you, this methylene blue dye we have used. So color rejection is almost 100% in both the cases, M1 and M2. And one more important thing, why we have used TiO2 nanoparticles? Because of the photocatalytic activity of TiO2 nanoparticles. So what happened? You can see here this whenever this foul membrane means membrane after operation. Whenever we expose this membrane with UV light, so this TiO2 nanoparticles this get this because of this nanoparticles this dye degrade again. Okay, and we are getting the pure membrane. Right, means you don't need to replace the membrane. You can simply regenerate the membrane by exposing it into the UV light. So you can see here these are the picture of pure membrane, pure M1 membrane, pure M2 membrane, and these are the foul membrane means after operation. Okay, so simply the purpose of using DI-2 particles is to improve the flux, and also we can regenerate the membrane here in this case. Okay, so this is about this DiO2 nanoparticles. The another work that we have carried out is using MWCNT nanoparticles and sodium alginate. So sodium alginate is biopolymer. Okay, so we have already we have used PVDF polymer, MWCNT nanoparticles, along with sodium alginate as a biopolymer. So why we have used sodium alginate? Because we are already using this MWCNT. So sodium alginate is simply what happens whenever we are using another this means here in this case sodium alginate. So it creates an extra surface on the membrane that will help in fouling reduction and increase the mechanical properties of the membrane. Fine. So you can see again we have prepared again two membrane. Okay, N1 and N2. In the previous case, it is M1, M2, here N1, N2. So in the N1, we are using, if you are not using any nanoparticles, then that is called as pure membrane, fine. And if you are using some nanomaterials or some additive in it, then it will give you the composite membrane, fine. So this is the difference. So this N1 is we are using, we have used PVDF and DMF as solvent, and in the second membrane MWCNT means sodium alginate as nanoparticles and additive. Okay, so you can see here simple, these are the simple properties. Okay, this pure means what is the purity of this here. Okay, so I think, and you know about this multi-wall carbon nanotube, so it is simply having a structure of layered structure of graphite layers. Okay, so okay, and we also carried out the carboxylation of MWCNT using sodium chloroacetate and KOH. Again, the purpose of this carboxylation is to improve the functionalization of the membrane. So this again we are going to add this MWCNT and KOH solution with water. Then we have to mix it. Then sonicate it for mixing purpose. Then for 3 hours at 100 rpm, 90 degree centigrade temperature. So it is very important to maintain the temperature and other operating conditions. Actually, I want to share one thing that right now my students are facing a lot of problem with membrane preparation because they are not sometimes what happens, dope solution is not prepared properly. Sometimes there is maybe the change of the temperature, even the humidity of the lab, means humidity of the environment, and whatever the temperature and humidity is present at that time in the lab, that will also affect the membrane. Fine. So you can see it is you miss, you are thinking that it is very simple. No, it is taking a lot of time, and many of the time membranes are not prepared properly. If there is one small hole is there, then we are going to discard it. Fine. So it is simply a step of carbonization of nanoparticles. So you can see this is this is a final nanoparticle. Okay, and again these are the steps for membrane preparation, that the steps are same as that of previous one. Okay, so I'm not going to explain here in detail. So simply I want to tell you that it is for pure PVD. These steps are for pure PVDF membrane, that is N1, and these steps are for N2 membrane. Fine. Okay, again we are going to measure the contact angle, porosity and thickness of the membrane. So here you can see, because we are functionalizing the membrane and we are adding sodium alginate also, so you can see a thickness of the membrane is increased. Okay, in the case of N2. Fine. Porosity is increased, and again the contact angle is little bit decreasing. Okay, but at the end we have to check the what will be the effect of this addition of MWCNT or assay on flux and rejection. Okay, fine. So these are the AFM images of our membrane. Okay, so we also run our experiment for 100 hours. Okay, so after 100 hours we have to check that what will be the stability of our membrane. Okay, so after the 100 hour of experiment run, continuous run of 100 hour, so we can see we have observed this AFM image of membrane. Okay, and this for pure this first one is for pure PVDF. This one is for fouled. This is pure PVDF MWCNT assay, or this is fouled PVDF MWCNT assay. Okay, and the surface roughness is increases in the case of PVDF MWCNT assay. Okay, so I think I have forgot to add this RA or RQ value here. So in the AFM, they generally give the value of RA RQ, and by which we can identify the surface roughness. So by addition of this, surface roughness is increases, or surface roughness is increases means the membrane become more hydrophobic, and the flux will increases. Fine. So okay, these are the images for contact angle. Okay, that I have already explained. This contact angle is generally used to measure the hydrophobicity of the membrane. Okay, then these are the same images, okay, of pure PVDF and fouled PVDF. So you can see fouled PVDF MWCNT assay membrane is completely fouled. Okay, you can see, you cannot see any pore here. Okay, pores here. So this because of this 100-hour operation, because after 100, why we have stopped the experiment after 100 hours, because there will be no permeate in the permeate side, because the membrane completely fouled or blocked by the feed particles. And this work we have carried out for desalination application. Okay, that I'll show you. Okay, again this is simply shows the value of flux with the how fluxes we are getting with increasing the temperature with concentration. Okay, this feed flow rate, or here temperature, when we are going to increase the temperature, you can see fluxes increases, rejection is almost constant. Okay, in all the cases you can see. Okay, the reason for that I have already explained. Fine. In the case of concentration, the flux is decreases. Why? Because we have some concentration polarization is there. Because as we are going to increase the concentration, there will be the increasing in the salt deposition on the membrane surface. Feed flow rate, of course, when we are going to increase the feed, this feed flow rate, then there will be the high movement or the turbulence increases of the membrane surface. Sorry, and more vapor will pass through the membrane. Right? Okay, and okay, and again, when we measure the permeate flux. Okay, so in the case of PVDF, MWCNT or MWCNT SA membrane, it shows flux 25% higher as compared to the pure PVDF membrane, that is 5.10 kg per meter square, and here in the case of this composite membrane, it is 6.38 kg per meter square R. Okay, and this is simply showing the flux value, okay, for PVDF and flux and rejection value. Okay, so you can see as the time is increases, the flux start decreasing. Okay, and after 100 hours it becomes constant. Okay, and similarly, and this is for rejection. This is for this rejection. Oh yes, yeah, this is for flux. For this red one is for PVDF, MWC, and TSC, and this is for flux for PVDF, pure PVDF membrane. And one more thing you can observe here, the flux is higher in the case of composite membrane as compared to the pure PVDF membrane. And these are the rejection value, and you can see it remains almost constant over the period of time. Okay. Okay. So after nanomaterials, we can use MOF for preparing the membrane. Okay. So MOFs are right now, it is most popularly used this component for different applications. Okay, so right now we are also working on the gas separation process. In that we are working on some more, but I'm not going to discuss in detail. Okay, so I just want to give a brief idea of MOF. So MOFs are simply, I think you know if about this. MOFs are organic and inorganic hybrid solids with infinite uniform framework structure. Okay, means it's simply made up of organic and inorganic material. So if we are talking about organic, so it made up of some polymers, and if you are talking about inorganic, so some zeolite or some metals are there. So it is simply an organic and inorganic hybrid. Okay, in organic or inorganic hybrid materials. Okay, and what is the purpose of using MOF? So these are the some advantages of MOF. These are highly crystalline porous materials, and they are generally used for water and wastewater treatment applications. They are highly tunable, means you can changing the concentration or changing the value of different parameters. You can change the properties of MOF very easily. Distinct pore structures and high specific surface area. So all these properties we require for the membrane, and that can be fulfilled by the MOFs, right? But of course, if it is having some advantages, so disadvantages will also be there. So this high cost, poor mechanical properties, complicated synthesis processes, these are the main problem with this MOF. Okay, so it is so preparation of MOF is very complicated. Okay, it generally takes 6 months, 7 months, 8 months. If your reaction is okay, then it will take minimum this much of time. Okay. Okay, so these MOFs are inorganic porous materials, and it can be used as fillers with polymeric membrane. And whenever we are using this MOF in the membrane, so whatever membrane we are getting, so that is known as mixed matrix membrane, triple M. Okay, that is hybrid composite membrane. And here in the case of this mixed matrix membrane, we are taking the advantages of both inorganic porous material or organic polymer, because we already used some polymer for membrane synthesis, and inorganic porous materials comes from the MOF. Finally, comes from the MOF. Fine. Okay. Then another challenges with the membrane preparation is that highly compatible connections between the two phase is challenging issue. Okay, so you are mixing organic part with the or inorganic parts. So how you are going to make a connection between these two phases? It is very challenging issue. Fine. So till now, different type of MOF already have used. People are working on that, like UIO, HKUSD, MIL, and recently one of my PhD student have we along with the PhD student we have prepared this SVNIT 1 and SVNIT 2 MOF. Fine. So this MOF are completely new. We have used completely new ligands. Okay, and along these ligands have prepared in lab, and these ligands we have used with the zinc and cadmium metal ions, and we prepare a new completely new MOF, and then this new MOF we have used for iodine sequestrations. Fine, and this work has already published in 2025 in Small Methods journal. Okay, so you can go if you want to learn more details about this, then you can go through this paper. Fine. Okay, so this MOF can be a supporting material and can be used directly as a thin film, or it can mix with the polymers and to make a triple I membrane, mixed matrix membrane. So you can use in two ways. Okay, it depends on your application and your conditions. Okay, so this is one of the work in which we have prepared this hollow fiber. Okay, that I discussed initially that membranes can be flat sheet or hollow fiber. So this work is based on the hollow fiber membrane and along with some MOF. So again, we have prepared two membrane. So one is pure PES. So in the previous cases, we have used PVDF membrane, but now in this case, we have used PES polymer along with MIL 101 CR. This is your MOF. Here, the metal I use is chromium. Fine. Okay, and these are the NMP is your solvent that we have used. Okay, and these are the conditions of hollow fiber membrane preparation. So there is a completely different setup for hollow fiber membrane preparation. So we have used this. I'll show you, and these are the conditions. Okay, the parameter that we have used for the membrane preparation. This spinneret outside diameter. Spinneret is okay. I'll show you. Okay, I think it is in the next slide. Okay, so you can see, okay, this is the process. Okay, spinning process of hollow fiber membrane preparation. So these are the pictures of membrane that we have prepared. So you can see here, this is the polymer solution we have to add. Just a minute. Okay, we have to add in one of the chamber. Another chamber, there is a bore fluid, and through this wall it is going to pass, and this is the spinneret. Spinneret is simple and needle like structure, so through which this polymer is going to pass, and we are getting this hollow fiber membrane, and this is your storage tank. So I simply want to show you one video, I think, so you can see. You can see, so this type. Okay, so this is your this storage tank. You can see this is the hollow fiber membrane, and they are directly coming into this water is there. Okay, so you can see very it looks like very easy process, but the main thing is that you have to maintain the viscosity of the polymer. So in last year, one of my MTech student work stopped for 2 months because there was some problem with the viscosity of the dope solution, and it was not going to pass through the spinneret. Spinneret is simple needle-like structure, so you have to maintain a pure proper consistency of your dope solution so that it can be easily passed through this spinneret, and we can get the hollow fiber membrane, this type of membrane. Fine. So okay. This is the module, okay, that we have prepared in the lab. Okay, so prepared by the student herself. Okay, so that we have used. So you can see here, these are the membrane, hollow fiber membrane that we have used. Okay, Okay, so these are the characterization of this move. So you can see we are getting a very good. We were getting means the results were very good, and the structure you can see here. Okay, this is flower-like structure of this move that we received. Okay, okay, these are the FTIM images. Okay, simple. So okay, and these are the FEC7 images of cross-sectional view because we have used hollow fiber membrane. So you can see this is the cross-sectional view. It is very, we can see very, the hollow structure is very fine here. Okay, and you can see easily. Okay, through it. Fine. Okay, so these are the simple SEM images. Okay, then these are the again okay AFM images. So I have okay. So these are the RA and RQ values. So you can see here this there are surface roughness increases in the case of MOF membrane. Okay, it becomes 20.4 and RQ becomes 27. Okay, so surface roughness increases, and that is the main aim of this creating the membrane or using MOF. And again here this figure shows the contact angle of this both the membrane, and this is shows the tensile strength of both M1 and M2 membrane. Okay, okay, and okay, I forgot to tell you that this work we have used is this membrane we have used for rubber industry wastewater. Okay, so whatever wastewater coming from the rubber industries, so that we have used. Okay, and then we have checked the COD, BOD, TSL, and TDS for removal of all these components for M1 and M2 hollow fiber membrane. So these are the results, and in all the cases you can see that in the case of M2 membrane the removal is very good or higher than the pure PS membrane. Okay, so this is for COD, this is BOD, TSS, and this is for TDS. Okay, and this is your the picture for the porosity and mean pore size of the membranes. Okay, so okay, fine. Then okay, so here we have mentioned this PWA is pure water flux. So you can see in the case of M2, the water flux is increases. And one more thing I want to mention here that in the case of flat sheet, you see the flux is around 5.6 or 6.81 kg per meter square hour. But in the case of hollow fiber membrane, the flux you can see it is around 82 liter per meter square hour. Fine. So the main difference with using hollow fiber membrane is that of course the synthesis is complicated as compared to flat sheet, but the flux is very much higher than the flat sheet membrane in case of hollow fiber membrane. Okay, and this is and again we run the setup for 240 minutes. Okay, here because we have used this setup for MBR. Okay, so in the previous two cases we have used MD, but here we have used MBR process. So we run it for 240 minutes, and we see that then how this flux is going to means after cleaning the flux is decreasing. Okay, you can see with the time up to 120 minutes. Then we are going to clean the membrane, again use it, then flux increases. Okay, and you can see again it start decreasing. Okay, so regeneration is there, but again after some time it start decreasing. Fine. Okay, uh, another work is preparation of okay, we have time. Okay, another work is related to again the same the hollow fiber membrane preparation, but here we have used UIO66 MOF. Okay, so this is simply a preparation of MOF. Okay, UI6, and here in the second case we have functionalized this MOF with HBN. Okay, so why we have did this to increase the desalination efficiency of the membrane. Okay, that we have proved also. Okay, after adding HBl, the flux is increases. Okay, so this is simply step, and the MOF prepared in the laboratory was using hydrothermal method. Okay, so this autoclave we have used for, and in this we have kept this this feed component ZrCl4 and BDC, benzene chloride. Okay, so it's simply steps by which we prepare the MOF. Okay, and then okay, this is the composition. You can here we prepared three membrane. Okay, pure PVDF in which MOF is 0, then UiO66 PVDF with 1% MOF, and this with HBN. Okay, so with HBN it is again MOF we have used is 1. Okay, so these are the simple the characterization or FECM image of UiO66, and the second one is for SBL UiO66. Okay, again we have prepared the hollow fiber membrane, so you can see the images. It was very nice results. Okay, because we can easily see this hollow structure here. Okay, then again the operating parameters, effect of operating parameters. So here we consider the feed flow rate and temperature or concentration as a parameter, and we observe the flux flow for all these three membranes. And okay, and you can see here rejection. So okay, so we have checked this all these three membrane for different type of salt. Okay, so here we have used NaCl, KCl, MgSO4 and CSO4. So you can see these are the flux value, these are the rejection for M1, these are for M2, and these are for M3. Fine. So rejection is almost very good and consistent for all the membranes. Okay, and flux can vary. Okay, and you can see here in the case of M3, flux is highest. Okay, as compared to M1 and M2 membranes. Lowest for M1 and highest for M3, because again using MOF, and this MOF is again functionalized with HBM. Okay, then we have also checked the long-term stability performance of this membrane. So you can see here with the time it is decreasing, and we run the experiment for again 80 hours. Okay. Okay, so this is the last case study. So here we have used, I think you heard about P-phase, okay, P-phase compound, perfluoroalkyl compound. So these compounds are very generally known as forever chemicals, because they are having a fluorinated component in their structure. Okay, so and they are generally found in the tap water or this industrial wastewater, and coming from different industries like the cosmetic industries, paint industries, etc. So the treatment or of this PFAS chemicals are very very tough, and very less amount of work has been done in this area. So we worked on this. Okay, so we prepare again this MOF containing membrane for this removal of perfluoroheptanoic acid. This is one of the PFAS compound. Okay, and using membrane distillation, and this work is already published in a process safety and environmental protection paper. Okay, so okay, I'm not going to explain in detail. So simply these are the steps, okay, by which we have prepared the membrane. Okay, the same process steps are there. Okay, so finally we are having this water bath, and this. So this is a picture of your membrane casting machine. Okay, right. Okay, so these are the SAM images. Then the epicellular. So you can see here again we got very good this MOF structure. Fine. And then okay, these are the value of the permeate flux. Okay, so this permeate flux we have this obtained experimental value is 13.26 liter per meter square hour, and rejection. Okay, so here in this case the rejection is experimental rejection is 79.64. Fine, containing MOF. when we are having 2% of MOF, 18% of PVDF, and solvent 2%, then we are we got this results. Okay, and okay, and this is again we have run the experiment for 84 hours, and you can see this rejection is permit flux is decreasing. Okay, and then after 84 hours it becomes constant, and these are the value of membrane thickness, porosity. So you can see the CuBTC, MOF, PVDF, or this porosity is 62%. Fine. And actually this the membrane also prepared by two methods, single coagulation method and dual coagulation method. So this, in the dual case, it little bit higher than single coagulation method, the value of porosity. Okay, and then we compare our work. Okay, so you can see here in our work, this the flux that we observe is 13.26, but till now nobody has done work on the removal of P phase using DCMD process and using this CuBTC PVDF membrane. So our work observed this much of flux and 79.6 around the rejection of P phase compound. Okay, so that was very very good results. Okay. Oh, one more thing is there. Okay, I quickly wind up this. So currently we also work with MCOF. Okay, MCOF is simply the combination of MOF and COF. Fine. So MOF is metal organic framework and COF is covalent organic framework. So we here in MCOF we are taking the advantages of both MOF and COF. Fine. So okay, then so I have already okay. So and MOF are crystalline materials that made up of metal ions or cluster, and they are generally linked with some ligands. Okay, and they are known for high surface area, porosity. Okay, that we have already discussed, and stability can be the limitation. Okay, and in the case of COF, the COF are porous crystalline material, but they are completely composed of organic building blocks and connected together by strong covalent bonds. Fine. So COF are having excellent stability, but it may have the limitation of functionality associated with metal ions present in MOF. Fine. So you can see here, in the case of MOF, stability is the limitation, but in the case of COF, stability is very good. But here they are having this limitation of the association with metal ions that present in MOF. Fine. So what happens? This metal covalent organic framework comes into the existence that bridge the gap between MOF and COF by incorporating metal ion or cluster into the structure of COF. Fine. So COF and MOF by combining together results into the MCOF. So this approach allows for the creation of materials with the desirable properties of both high surface area and porosity of MOFs and stability and tunable structure of COF. Fine. So what we are doing, we are combining MOF and COF and getting the advantages of both MOF and COF. The advantages of MOF is high surface area and porosity, and the COF stability and tunable nature. Fine. And the new component that we are synthesizing is MCOF. Fine. So this work has not published yet. Okay, this work has already submitted in some paper, some journal. So you can see here we have prepared MCOF by using there are two methods, Pyrex tube method or hydrothermal method. So we have used both the methods. Okay, there are not very much difference between these two, but we have prepared by using both the method, and then we are having this dry Cu3L3 powder. This Cu3L3 powder is mixed with the TABB and macetylene and then dioxin and acetic acid. So these are the different this additives that we have used. So simply at the end we are getting this CATB COF powder on the filter paper, CuTABB. Okay, so Cu the copper and TABB is 135 tris 4 aminophyllite benzene COF nanoparticle. Okay, so this Cu for metal organic fiber and this one for component organic framework. Okay, so this we will we have prepared this AMCOF, and then this AMCOF is we have used for the membrane preparation, PVDF using PVDF polymer and NMPS solvent, and the the recovery that then we have tested it with THF recovery, and so you can see here this flux is okay. So this, we prepared 4 membrane, and this 4 membrane preparation depending on the concentration of AMCOF. So we have used 0, 1, 2, 3% of AMCOF. So by increasing the AMCOF percentage, you can see flux is increases. Okay, and the recovery is almost same. Okay, in all these 4 membrane. So, and this these are the same images. Again, you can see very good images of MCOF we have achieved. Okay, so this is again flower like structure and very beautiful structure. Okay, so these are the membrane before and after use. Okay, so before use it is like this. After use you can see here some foul or some salt components are there. These are the water contact angle of this CUTVB COF membrane. So, so this is around 71.8 degree. Fine. So okay. So this is all about this membrane technologies, and these are the some references. And thank you for listening. And now session is open for question and answer. Please, if you have any doubt, you can ask. I hope I'm able to clear something, some points to you.
Yes, thank you, madam. It is very well explained by you.
Thank you, ma'am.
Participants, if anybody have any question, you can ask now.
Anybody have any questions? So please ask. I will be very happy to give the answer. So I think participants having dinner time, so they are not taking much interest.
Yes, participants, if anyone has any query, you can ask.
So I think there are no query.
Yes, it seems like.
It's okay. It's fine. It's fine. Okay.
Yes, participants, if anyone has any question, you can ask now.
Oh, thank you, Mr. Ajay. Thank you.
So we conclude here, madam.
Okay, thank you, Dr. Sushma, for inviting me or for delivering this session.
Yes, on behalf of the organizing committee, I extend my sincere thanks to Dr. Sarita Kalla madam for enlightening FDP session on hypersaline water issues and membrane separation process. She clearly explained the principles and applications of membrane technology, including nanofiltration, and elaborated on the advantages and applications of MOF-based membranes, highlighting their uses in day-to-day practical life. She also introduced MCOF and its role in advanced membrane design, uh, and supported her discussion with practical demonstration and laboratory results, which help participants understand real-world applications. The insights on nanoparticle enhanced hydrophobic membranes were especially valuable. We are grateful to Dr. Sarita Madam for sharing her expertise and valuable time. Thank you. Thank you very much, ma'am.
Okay, thank you, ma'am. Thank you. Okay. Okay. So can I disconnect?
Yes, ma'am. You can.
Okay. Okay. Thank you.
Uh, Participants, just wait for a few time. Our next expert is about to join. Participants, please wait. Our next expert is about to join. Hello, dear participants. Sorry for inconvenience. The Our expert Dr. Pandya had some emergency, so he will join shortly. Please wait. Good evening, all. We have now with us our next expert for the session, Dr. Chintan Pandya, sir. He is a seasoned quality control and quality assurance leader with over 15 years of experience in pharmaceutical industry. He currently serves as Head Quality Control and SPC Life Science Limited, Ankaleshwar, where he leads comprehensive QC operations encompassing analytical testing, method development and validation, product release, stability studies, and regulatory compliance. Dr. Pandya has extensive expertise in quality management system with ISO 9001, 14001, and 45001, data integrity and 21 CFR Part 11 compliance, and global regulatory audits including US FDA, EDQM, and ANVISA and ISO, with a proven track record of successfully completing 35 plus audits with zero major observations. His strong focus on Six Sigma, lean, and continuous improvement has resulted in significant reduction in laboratory errors, cycle time, defects, and operational cost. He holds a PhD in chemistry and a postgraduate diploma in intellectual property rights and has contributed extensively to academia and industry through 25 plus publications, 7 authored books, and 40 plus industry collaborations. Dr. Pandya is a frequent invited speaker, trainer, and session chair known for translating regulatory and quality principles into practical high impact manufacturing excellence. Now, I request sir to proceed with his session on quality control and assurance. Over to you, sir.
Thank you very much, ma'am.
Yes, sir.
Thank you very much, ma'am.
Welcome.
First of all, on behalf of SPC Lab Science, I'm presenting this quality control and quality assurance department to you. But for giving me this wonderful opportunity, thank you, ma'am, as well as thanks to Vidyapeeth University and the management staff for giving me such a wonderful opportunity. Should I start with my presentation, ma'am?
Yes, sir.
Yeah, thank you. Okay, the presentation, I guess everyone can see.
Yes, sir, it is visible.
Yeah, okay, thank you. So, we'll make it somehow interaction. It's like two-way interaction will do, right? So, I will ask some question and I will definitely expect some replies, whatever the faculties or the participants know. So, first of all, I will start with the basic introduction of mine, as well as ma'am has already introduced me. Uh, I'm right now I'm looking quality control and quality assurance department at SPC Lab Sciences Limited at Ankleshwar. We are a large manufacturer of active pharma ingredients as well as the active pharma intermediates which are to be used to make active pharma ingredients, and the post it is used to formulate tablet capsulation as well as the injectable items. So this is a brief introduction of my organization also. Our organization was started at in the year 2005. So right now it has already completed more than 20 years, and we are dealing with the largest pharma companies of India like Zydus, Sun Pharma, then Mylan, Alembic, and many more. As well as our business is expanded to the foreign countries, also like US, Europeans, and many more. So many clients which are we are dealing at those countries also. So I will start my presentation with the quality. Means like quality. While you are doing business with such means like renowned organization or renowned pharmaceutical company, quality itself it has its own importance. It's like it is not like that we are manufacturing something and it will be absorbed or it will be accepted by these large groups. It will definitely require a quality product. Means like they didn't require the product itself, but what are the impurity profiles? Means like nowadays the customers requirement are we can say uh, a, a totally 360-degree change what we have found in last 10 or 12 years. It's like before 2014 or 13 it was an era that everyone was demand about the product, the main product. No one was discussing about the impurity profile, or no one was discussing about the minor quantity which is already there as a byproduct. But nowadays the customer will ask you the first question. The main product is okay. Means like if you will give them or if you will deliver them a product having the 99.9% purity, then also they will ask that what about the 0.1%. Means like what are the byproducts and what are the impurities are there in that particularly 0.1%. So they are interested in this 0.1%. They are not interested on the 99.9% product which you are delivering. They are more interested or they are keen interested to know about what are the impurity profiles of that particularly 0.1%. So in this era the quality plays a very important role if you want to grow your business with such a huge partners. So the quality control as well as the quality assurance department plays a significant role in this particularly demanding area. So today's my topic is lying with the quality control and quality assurance department. These are the two pillars of any pharmaceutical industries nowadays, and without their approvals the manufacturing product cannot be dispatched or cannot be delivered to any customers as well as to any country. And if you have produced such a huge amount of I mean, it's like tablet or capsule or any other product or like injectable, but if it is not passing the quality parameters, it does not have any meaning. It's like it is, we can say that just similar to a trust. It's like it does not have any importance if the batch is of 5 lakh rupees or if the batch is of 5 crore rupees. It does not have any importance if it does not clear the quality parameters or it does not clear the quality control or quality assurance specifications. So nowadays, this much importance is given to these two departments. Means we can say that these two departments are run the business. Manufacturing department is just producing the certain product, but the quality department is actually sitting on the driver's seat. Those means like who can drive the business. So nowadays, this much importance are given due to the various requirements or various demands by the different regulatories or different customers. As we are lying in the pharmaceutical business, it falls in the Six Sigma. Means like Sigma is a parameter through the safety is measuring. Means like if you have heard, the highest business in this world nowadays, which follows the safety parameters in a very highest demand, that is aerodynamics. Those who are manufacturing the aeroplanes or the helicopters, like Hindustan Aeronautical Limited, or like the Boeing, those who are producing the aeroplanes or the helicopters, these companies are following the highest safety parameters, and the safety parameters are measuring in a sigma format. Sigma is a unit to know the safety parameters or to measure the safety parameters. They are following the 16 sigma. 16 sigma is the highest parameter followed by any business, and afterwards means the second number of a business, type of business which are following the second highest safety parameters, that is pharmaceutical business. And as a pharmacist, we are falls in a six sigma business, means like six sigma measurement. So aerodynamics industries, they are following the 16 sigma. Afterwards, the pharmaceutical industry, who are following the six sigma parameters. The reason behind that means like in manufacturing of any aeroplane or helicopter, we should not accept any single mistake. Means like if a single screw is not fitted well, then at the height of 50,000 feet, or at the height of means like 50 or 60,000 feet, you will not get any second chance to control that particular aeroplane or helicopter, which is having more than 500, 600, 700 passengers. As in means like just before 2 or 3 months ago, we saw that due to one mistake of a pilot, and at Ahmedabad Air India plane, how many people have just lost their lives. So that's why they are following in a 16 sigma. Means like they cannot accept, or means like they cannot. We cannot expect a single mistakes from those from them. Now, afterwards, the pharmaceutical business, they are following in a six sigma parameters. Means like in a pharmaceutical also, we cannot accept a single mistake by any employees or by any pharmacist, because the pharmaceutical product are generally when it is formulated, means like the three stages are there. The intermediate stage, which are nothing but just a chemical which can be useful to manufacture the active pharmaceutical ingredients. And this is the active pharmaceutical ingredients, that is the second step. And afterwards, the API, active pharmaceutical ingredients, which can be useful to produce whether the tablet, capsule, or injectable, or sometimes ointment, or we can say the oral syrups. So these are the three steps. Generally, we are consuming the final formulation product, means like either the oral syrups or the ointments, the injectables, or the tablet or the capsules. But once they are manufactured, we cannot accept the single mistakes done by the intermediate stage, done at intermediate stage or API stage, because the end users are human beings. We the end users, means like the end users are humans, and they are, that means like the live, we can say the live entity. So means if we will done any mistakes in any stage of pharmaceutical formulation, so many lives can be we can put many lives in a dangerous mood. So that's why the pharmaceutical industries are following in the Six Sigma business. And that's why this much importance are given to the quality of the product of the pharmaceutical business. And this is the importance. Now, I will come to my point again. Means like, yeah, to understand the concept of quality, Uh, quality means it is a combination of quality control as well as the quality assurance. But both department are independently work. For quality assurance, we can say that in a simple language, the quality assurance department will work as a police department of pharmaceutical. Means like they are not directly involved in any activity. Means like they are not involving in a manufacturing. They are not involving in the
Uh,
engineering department. Also,
Excuse
they
me,
are.
sir.
Yeah, please.
Sir, the slides are not changed. We stuck to single slide only.
Just a minute. Yeah. Actually, here it is changing. Just a minute. Okay. Yeah, now it's changed.
Yes, sir.
Yeah. Okay. Yeah. So, generally, quality assurance department is independently work. Means like they are working to check the quality of each step. Means like if it is manufacturing, if it is engineering, if it is ETP, effluent treatment, if it is safety, even though if it is HR, human resources or admin department, or if it is quality control department. The work of quality assurance department is to monitor each and every department and to ensure whether those departments are work as per the written procedure or not. This is the main concept of quality assurance department. Means like they are working as a neutral department as a pharmaceutical, means like in a pharmaceutical company or pharmaceutical organizations. It's like they are not directly involved in any activity, but they are monitoring each and every activity. Means like QA is a part of each pharmaceutical step, to starting from raw material, warehouse, manufacturing, quality control, then ETP, then safety, engineering, and even though HR and admin. So they have to monitor or they have to ensure each and every activity. It's like in pharmaceutical industry, we cannot do any activity by our own selves. The written procedures are already made, and it is known as the standard operating procedures, the SOPs, and every department has to follow their own SOPs. Without SOP, they cannot start or complete any work, and the QA department has to monitor whether those department are work as per the written SOPs or not. If they are not working, then quality assurance department is raising a deviation. Means like you are not working as per your written procedure mentioned in so and so SOPs, and after raising those deviation, the root cause analysis means like why you are not following your SOP. Suppose quality control department is not following its SOP, then quality control department has to raise the deviation that why we are not following our SOP. It's like suppose for example, if quality control analyst is just doing the sample preparation, and in sample preparation it is written in the SOP that the analyst has to take 25 milligram of sample and has to dissolve it in a 50 ml of a methanol solution. And if the analyst has not taken exactly 25 milligram sample, instead, if he or she has taken 30 milligram sample, then the QA person, the quality assurance person, will raise a deviation that your person is not following the written SOP. It is written to take 25 milligram, but your analyst has taken the 30 milligram. And through this, we have to find out the root cause why we are not following, or why our person, quality control person, is not following the written SOP. What are the root cause? Means like what was the cause behind that particular analyst to not following the written process? And after that, finding the root cause analysis, the proper corrective and preventive actions we have to take to prevent this type of error in future. Likewise, quality assurance department is monitoring the all departments of pharmaceutical industries. and all department has to follow their written procedure very strictly, because we are dealing with the human. That's why we cannot deviate our written procedure. And this strict monitoring are made to just maintain the quality of the product. It is nothing with the we can say with the it is not like the military rules, but to maintain the quality, such strictness are necessary. So this is the basic function of quality assurance department. While the quality control department has to focus consistently on the quality, as well as applied the quality to product and services, because the customers are only delight if we are delivering them a consistent product with the consistent quality. So nowadays the competition is there, and many competitors are there who are manufacturing the same product. So if you are not delivering the same product with the same quality, then definitely the customer will choose your option. So to be strict in your business, or if you want to grow your business in this business, then you have to stick to your quality, to your product, as well as deliver the same quality again and again and again. So the customers will definitely make a strong relation with your company, and they will not move here and there. So the quality plays a bigger role to stick your customers and in the growing of the business as well. Why the quality is such important? To reduce the defects and failures, means like, if you will not monitor the quality, then what are the mistakes are happen during manufacturing, we cannot identify. To identify the mistakes and to prevent it in a future, you have to strictly monitor the quality. This is the role of quality control department particularly. Maybe the failures are happen, but we have to take these failures as an experience. Means like, okay, if we will get the failures, it is not like the that we will do it repeat again and again. To reduce this type of defects, we have to go in a deeper to identify the root cause. And once the root cause is identified, whether the mistakes was happen at quality control department during the analysis, means like the quality control analyst has not prepared the solution properly, whether he has not taken the chemicals properly, whether he or she has not taken the glassware properly, means like instead of 5 ml pipette, if he or she has taken the 4 ml pipette to prepare the solution, instead of acetonitrile, if he or she has taken the methanol, due to hurry or due to the, we can say, overconfidence sometimes. So we have to identify the root cause in two phases. The first phase is related to the error identification at quality control department, whether the analyst has properly followed the SOPs, whether he or she has taken the chemicals as written or as mentioned in the written procedure, whether he or she has taken the proper glassware as mentioned in the written procedure, whether he or she has taken the instrument as mentioned in the written process. After confirming all these quality control parameters, if no root cause is identified at quality control laboratory, then we can move to production department. If the failure is not happened due to QC department, definitely the failure is happened due to some mistakes happened during the manufacturing of the product. So there also we are following the reverse chronological order investigation process. Reverse chronological order means start from the end. what was the end process of manufacturing, whether it was properly done as per the written procedure, then the second last procedure, then again next up to the initial point of the manufacturing. And definitely in this reverse chronological investigation will find the failure at one of the step, and once the error is identified, we have to take a corrective action and a preventive action. It is known as the kappa of the pharmaceutical industry. Kappa, CA means the quality, means like the corrective action, as well as the PA means preventive action. After identifying the error, we will initiate the corrective as well as the preventive actions. Corrective action means what we should take action right now to control this failure. And the preventive action, what should be our step to prevent this type of same error in the future. So these two are the main pillars of any investigations: corrective action as well as the preventive actions. And to identify the defect or the root cause, we are generally following this many tools: the Pareto chart, fishbone diagram, flow charts, control charts, and finally the RCA, root cause analysis. Uh, Means like in a short language, or means like in one sentence, if I want to sum up this all, these are the different tools only, but it all take you to one end, and that is why this error was happen. So starting from the QC to production, we have to identify whether the human error was there. Means like 6M generally we are following. 6M means the error due to first M means man means the error was due to human. Means like human error was there. Like I already said that if the analyst has not taken the proper glassware or proper chemical, so it will be definitely taken as a human error. So first time, that is due to, if the error is happened due to a man related error. M means like if the first M is clear, means like if the error was not due to man, then the second M, that is related to machine, whether the equipment was working as per the means like expectation, or whether any defect is lying at the equipment or instrument. So we have to investigate the instrument or equipment thoroughly. Means like what was it calibration frequency, when it was lastly calibrated, what was the calibration result, and what was the last analysis result done with the same instrument, whether it was pass or it was fail. So likewise, all impact assessment we are doing to identify the error if it is related to machine. So first M, that is man, the second M, that is machine, the third M, that is the measurements means like measurements means like whether it was properly analyzed or not. Means like the proper chemicals glassware are taken or not, or whether the process was followed as per the written process or not. Then the fourth M, that is the mother nature of the product. Means like sometimes in pharmaceutical industries, what happened that some products are light sensitive, particularly the oncological product. So the sample before analysis, whether it was exposed to the light or not. Some materials are having means like they are we have to protect it from sunlight, direct sunlight. So whether the material was exposed to the sunlight before the analysis, and due to that this deterioration was happen. Sometimes the products are temperature sensitive. So whether the temperature means like we have to store in 2 to 8 degrees Celsius. and whether the sample was exposed to the more than 8 degree or 10 degree or at 25 degree temperature, and due to that this deterioration was happen. So this type of material nature, mother nature, we have to identify. This is the fourth M. Then the other two M's means like whether it was related to method, means like the method of at manufacturing, means like what they have to follow the process during the manufacturing, whether they have followed the same method or some skipping was happened during the manufacturing or not. So this type of 6M analysis we are doing, and out of this 6M analysis, we came to know that at what point particularly the error was happen and due to why. Means like it was due to human, it was due to the material nature, it was due to the measurements, whether it was due to the machine, etc. And after that, the error identification or the root cause analysis, we are taking those corrective and preventive action. Means like what right now we can take as a corrective action to means like resolve that particular momentary failure, and what will be our long term solution to prevent the same error in future. So these are the common tools we are following, and that's why the quality parameters are having this much importance. During this, what is the activity of quality assurance department? Once the failure is identified, the quality assurance department are generally focused on the approach. Means like how many same product batches we have earlier produced. The trend data they are with it is with the quality assurance department. So they will do the impact assessment. Earlier, this type of error was happen or not. If it was happen, then whether it is the repeat error or whether the error type is different. And if it was happen, then the prevent what was the preventive action taken at that time. After taking that preventive action, whether we are following the same preventive action or not. If we are not following the same preventive action, what was proposed during that particular error, then this error can happen repeat. So this type of training are prepared by the quality assurance department. Means like they are preparing the batch tree. Batch tree, we can say that the complete history of the product. Means like starting from the initial intermediate, the raw material, quality of the raw material, what are the vendors of raw material, whether that vendor was qualified or not to deliver this product to our company, or whether their audit was happen or not, whether their was cleared or not, whether their product was strengthened to produce our product or not. Means like whether their raw material was enough strengthened to produce this product or not. Means like the error was happened due to raw material or whether it is happened at our manufacturing. So this type of trending are generally doing by the quality assurance department. It's like they are preparing the batch tree and they are analyzing the each and every step of this production. Means like of this particular batch to identify the root cause. And once the root cause is identified, then they are suggesting the proper preventive action, that what should be the steps we have to take to prevent this type of repetition. It's like if it is happened due to any vendor raw material, then the first means like in first case the notice has been notice should be given to particular vendor that due to your deteriorated raw material product we are facing this failure. If after issuing this notice the same type of deteriorated raw material are again delivered to that particular company, then more strictness can be taken by the mother company, that maybe they can ban the raw material providers, or they can put it in a blacklist. So this type of actions are to be suggested by the quality assurance department. It's like, as I told in the beginning of the session, that quality assurance department are work as a police department of the pharmaceutical industry. It's like they are finding the errors, or they are continuously monitoring the quality, and what are the leaks are found by the any department, whether it was quality control, whether it was manufacturing, whether it was the warehouse, whether it was the raw material providers, or whether it was even the packing department or engineering department, or the even the HR or admin department. So they will definitely take preventive action to prevent this type of errors. And if in a primary actions the error is not means like we cannot find the resolution, then in the next step the strict action will be taken by the quality assurance department. So any we can say the final batch analysis are done by quality control department, but whether it should be delivered to the customer or not, the final approval has been always taken by the quality assurance department. Means like after doing the quality, means like after doing the analysis of quality control department has to submit their result with the supporting data to quality assurance department, and quality assurance department will thoroughly check each and every activity done at QC department as well as the manufacturing department. And afterwards, reviewing all these documents, they will take their own decision neutrally whether this product should be dispatched to the relevant customer or not. So the final approval authority are with the quality assurance department. So they are having the highest power in the pharmaceutical industry. But as we all know that the power comes with the responsibility. So after dispatching the product to any customer, if any failures are happen, then the final responsibility is lying with the quality assurance department. So they have to face the internal and external audits. So any type of audit are generally initially faced by the quality assurance department, because they are having all the data as well as they have already monitored all the activity. So they have to face all the audits, and if any support they need during the audit, then and then only they can call the relevant department. Means like quality assurance department are having all the rights, all the authorities, and they are involved in all type of activity from the beginning of the manufacturing. But though they are not expert to all quality parameters, like if the quality assurance person is there, but he has monitored the engineering activity, but he is not an engineer. So certain technical questions he or she cannot face. So they can take the help of engineering department. But the audit should be initially faced by the QA person only. Likewise, they can take the help of QC department. They can take the help of manufacturing department also. But initially they have to face the audits as they are involved in all activity from the beginning. Also they have to prepare the training, also they have to prepare the documentation, because in pharma we are believing that if you are producing something, if you are manufacturing something, or if you are analyzing something, but if it is not documented properly, then it is just a rumor. Means the activity is not happen in reality, it is just a rumor. Means like afwa, we can say the activity is not really happen, it is just means like we can say that it is just a rumor. If it is really happen, then it should be documented, whether it was manufacturing activity or whether it was the quality activity. all should be documented, and documented in a real time. Real time means when you are, for example, when you are checking the weighing of something, means like you are weighing any means like produce, if any sample is just weighing activities happen, or if you are checking the pH of that particular sample, after measuring the pH, the final pH answer means like if you have measured the pH and the pH was 4.53, so 4.53 should be immediately mentioned in the documentation after completion the activity. It is not like that you need to done certain 10 or 12 analysis, means like firstly you have checked the weighing of the sample, then pH, then you are doing the loss of drying, then you are taking the percentage water, and the fifth stage was running, but the first stage was not mentioned in the written document. It should not be like that. Real time recording means once the activity is completed, it should be immediately mentioned in the documentation. And the logic behind that is once the activity is completed, it should be immediately mentioned so the real figures can be I mean, it's like the real figures can be captured in the recording document. If we are not recording in a real time, there are chances that the manipulated figures are to be mentioned. So that's why the real time recording should be done at the time of activity. So this is known as the good manufacturing practices. And at QC, generally we are following the GLP practices, the good laboratory practices. Good laboratory practices are having certain parameters. Means like the Alcoa, generally we are at pharmaceutical industry, those who are following the GMP and GLP practices, they are following the Alcoa practices. Alcoa means ALCOA. The first day, that is attributable. Attributable means when who have completed the activity, when the activity was completed, and what was the activity done. Means at the end of document, the document should be signed and signed on current date. And who have signed, they have to mention their names also. Means like the third person or the layman can identify that this activity was done by so and so person on so and so date, and this is his or her signature. So the document can be attributable. This is the first day. The second demand of GLP and GMP practices is it should be legible. The document should be legible. Legible means it should be readable. Nowadays, the documentation are means like computerized, but the observation should be mentioned by the particular person. So they are mentioning in their handwritten, means like they are observe the what was the that what was their observation are mentioned in their handwritten only. But legible means the handwritten activity also should be in a legible format or in a readable format, so the third person can identify what was the observation of that particular person. And if any mistakes are happened during that handwritten activity, he or she can single strike that particular sentence or word. Only single strike. In between, means like in the middle of the sentence, the single strike only allowed in the pharmaceutical industry. It is not like that we should just make it round, and the third person cannot identify what was the written before. But in pharma, just we are rub it in a such a way that the single strike in between the word, and then we have to make a star or hash on that particular stamp and the strike mark, and at the end of the page we have to give the reason that why that strike mark was happened. Means like whether it was written error, whether it was measurement error, whether it was the, we can say, transcription error. Transcription error means the result was 25.421, and by mistakenly we have mentioned 241. 421 and 241 are known as transcription error. It's like in sleep it was mentioned 25.421, but mistakenly we have mentioned 241. So in this case, it can be written as this mistake was done by so and so person and it was transcription error. And for that, the proof is already there, the sleep is already there. So this type of single strike marks are allowed in document, and the document should be legible. Means after strike mark also the previous sentence or previous word should be readable. So this is legible. Then after the third, that is the contemporaneous. Contemporaneous means the real time recording. As we already discussed, the real time recording should be must expected in the pharmaceutical industry from the manufacturing and from the quality control department. The fourth expectation is that the original result, original means like the document what we are presenting to any auditors, it should be original. Original means it was not tempered, it was not manipulated, and the original recordings are mentioned over there, whether it was failure or whether it was qualified to. What was the initial observations are there, it should be recorded. Means like we cannot do the tempering or page changing or the manipulation in the document. It should be in an original format. So this is the O means originality, and the last A of the Alcoa system, ALCO, and the A. The last A is for accuracy. Means what we are mentioning on the document, it should be accurate. Means what we have got, we should mention the exact one, and it should be accurate means it should be as per the written process. So Alcoa system we have to follow, means like by the manufacturing department or by the quality control department, and these are the demands of audits as well as the good manufacturing practice and the good laboratory practice. And all regulatory, generally industry specific regulations, pharmaceutical industry specific regulation means like the customers with whom we are doing our business. With the regulatory means if we want to do our business with the US companies, then the US government will play an important role. We have to first justify our company or our group to US governments, US FDA. US FDA means the United States Food and Drug Department, and they will audit your company on the behalf of the US government. And if we are following their quality parameters, quality metrics, then and then they will allow you to start your business with the US companies. So likewise, we have to follow the regulations of the US FDA if we want to do our business with the US companies. If we want to start our business with the European Union, then we have to follow the EDQM. EDQM means the European Union Food and Drug Department. They will analyze your company, they will audit your company, and if we are fulfilled their expectations, means like the quality, legal, and the manufacturing expectation, then they will give you a green signal to start a business with the European companies. Likewise, if we want to start our business with the Brazilian companies, we have to follow the NVISA. NVISA is a name of the inspecting agency of Brazil. Likewise, for Australia, we have to clear the TGA. So many countries are having their own food and drug analysis agencies, and if we want to grow our business with those particular countries, we have to follow the rules and regulations, the legal compliances of their own country's government. And if we will clear those regulations, then they will give you a green signal. They will issue you a commercial certificate to start a business in their countries. Then after, the customer will come into the picture. Means directly we cannot start a business with the US or European or Brazilian or Australian or Japanese companies. We have to clear their government audit first, and then they will give you permission to start a business. Likewise in India, where we can say a domestic business, in our own country we have to take approvals of the local state FDA, the state FDA, then the central FDA, Food and Drug Analysis Department. Then they will issue a certificate to your company or your organization, and then you can start a business. So also India is following these regulations. It's like the quality manufacturing as well as the legal. And after a certain time they will it's like the frequency of the, if I will talk about the state FDA of India or the central FDA of the India, they are having frequency to audit your company in every 2 hours, 2 years. It's like in every 2 years they will inspect you again and again. And if your company is continuously following their parameters, then they will, after every 2 years and completion of successfully inspection, they will give you a certificate to run your business for more 2 years. Likewise, USFD is having the frequency of 2 years. Likewise, the European Union is having the frequency of 3 years. Likewise, the Brazilian government is having the frequency of 5 years. So different countries regulations and the inspection criteria are different. Also their frequencies are different. But anyhow, we have to follow their rules and regulation if we want to grow our business in those countries and with those customers. So these are the quality standards and quality compliances. With this, I want to sum up my presentations. Thank you, all of you, for your patience. If you have any queries or questions, the question and answer session I'm opening with this.
Thank you, sir. Participants, if anyone has any question, you can ask now.
Hello, am I audible?
Yeah.
Yeah, myself, Dr. Anand Maitre. My question is that what quality assurance or quality control you're talking about? So it is like NABL kind of certification you have to take like this, or
Yes, actually, sir, in India, we are having many different elements like the state FDA as well as the central FDA. What you are talking NABL, NABL is agency which is responsible to inspect your balance, then the engineering. They are inspect and they are having the issuance authority to check your balance, pH, then the engineering instrument, the manufacturing instrument. So the NABL is made to this. Also, they can give you approval to your quality control laboratory. Means the NABL accreditation, if you will get your quality control laboratories results which are analyzed at your laboratory can be accepted to all over India. So this is the importance of NABL in India particularly.
okay, okay. Thank you, sir.
Thank you.
Any
Sir, one more question.
yes.
Yes, sir.
So it is something off the track, but can you tell me about the people are talking about the generic like medicines or like that. So can you throw light on that? Means what is that generic, or we should consume that or not?
So, generic medicine is another means like they are having the same active pharmaceutical ingredients which are used to produce branded medicine. But it is something what we can say to understand that better. Means like the if something is manufactured by we can say the branded company like Tata or Adani or Reliance, like or means like if we are taking the example of what we can say that a shirt is made by the denim company or the Irving company. The same shirt can be manufactured by the local companies also, but
Yes.
also they are taking the fabric of the same quality. But the thing is they are not very well known, and hence they are not having the more expenses like the marketing, the highest salary persons, or the staff is limited to them. That's why they can make a cost to a limited certain limited means like if a local brand is making a denim shirt, then they can have a price of certain 300 rupees per shirt. But the same shirt is suppose if manufactured at Arvind Mill, they will make you the price of 1500. Though the quality are same, but as the Arvind Mill is the branded one and they are having the more expenses compared to local, so they will definitely make you a price of 1500, while the local customers will give you the same quality at the 300 rupees. So we can use the generic medicine, it does not have any impact on the quality. But the thing is, the generic medicines are produced by the local the smaller companies, as well as the branded means like the branded medicines are made by the very well-known pharmaceutical industries like Torrent or Zydus or Sun Pharma. Though the names are bigger and their expenses are more, they are taking the benefit of their names. This is the difference between the generic and the branded one.
So quality wise, there is no as such difference,
Yeah,
right?
quality wise, there's no difference.
Okay. Thank you, sir. Very nice session. I will
Yeah,
really enjoyed your session about the quality assurance and quality control.
yeah. Thank you so much, sir, for the wonderful appreciation.
Yes. Any other question? Participants, if anyone has any question, you can ask. Okay, so I think there is no questions from the participants, so we conclude here.
Okay, ma'am.
On the behalf of organizing team, I extend my sincere thanks to Dr. Chintan Pandya sir for the insightful FDP session on quality control and quality assurance. He clearly explained the concept of QC and QA, helped us understand the importance of quality systems, and emphasized why quality is essential in academic and industrial practices. The discussion on commonly used QA and QC tools, along with quality standards and compliance requirement, provided valuable practical insights. We are grateful to Dr. Chintan Pandya sir for sharing his expertise and valuable time, which made the session highly informative and enriching. I also thank all the participants for their active involvement. Thank you all.
Thank you so much, ma'am. It was pleasure to address this session, and Miss like I have enjoyed this with all participants, and they were actively participated in this session. They were listening with very patience. So thank you all of you.
Yes. Thank you, sir.
Thank you.